let me know if you can't hear me, because I've got quite a quiet voice. So I have to pretend my partner's at the back and I'm shouting at him. Welcome to my talk on Terraform. Thank you for coming. I'm Anna. First, what are we going to do? So what is Terraform? Working with Terraform cloud providers, working with other Terraform providers, and best practices when working in production. So I've used Terraform for the last few years. I used it when I was working for a big energy company, when there were countless developers using the big three cloud providers, and essentially I was in a small team where we managed microservices, and we used Terraform to do that because we could use it essentially across clouds, so across all the different providers, and we were all on the same page using the same technology. And now I'm working as a consultant. I essentially help clients to use it in their solutions as well, essentially. So who am I? So this is my little sales pitch. I am a Microsoft Data Platform MVP. I'm a senior consultant at Advancing Analytics, and I specialize in data engineering and cloud. So I've got over 16 years experience. So I was a software engineer for countless years, I think about 14, 15 years. And I'm now essentially a data engineering consultant. So I've got a variety of experience, say most recently working with Scala and Kafka. And currently, as a consultant, working in the Microsoft data platform. So anything Microsoft. And essentially, before that, I've got a BSc in multimedia computing and a HND in visual communications. So I'm a bit old school. I've been doing this for quite a while. And those are the links, firstly, to any code that I'm going to show you, and then just links to my LinkedIn and to Twitter. So what are we going to look at? So we're going to run through some of the basics. So who's actually used Terraform here? Or are we all quite new? OK, awesome. So working with a cloud Azure provider, so Terraform Azure resources, including resource group, Postgres database, VM, storage account, and network. So what I'm going to show you is in Azure, but this is something that you can use in the different cloud providers as well. So it's not an Azure sales pitch. It is obviously cross-cloud, so you can use whatever I show you essentially in the other cloud providers. So we're going to work with the Databricks provider as well, to essentially create a workspace, a cluster, notebooks. So the Databricks provider is essentially really growing at the moment. It is a provider that allows you to work with three big cloud providers, essentially. So you work hand in hand with those, with their providers, essentially working with the Databricks provider as well, to basically infrastructure as code and Devops, essentially for Databricks. So, and then we're going to look at how to apply and enforce dependencies between resources, to how to manage state, and how to explore the Terraform deployment plan, and how to work with Terraform in Azure DevOps, essentially. So how to actually put Terraform into a pipeline. So there's some of you here that haven't used Terraform at all. So some of you, those who have actually used it before, some of this will be pretty basic, but hopefully you'll still take some stuff away from this, some sort of gotchas and best practices. And for those who haven't used it before, I will go through the basics and explain to you essentially how you set up Terraform, how you get going with that. So what is Terraform? So Terraform is one of the most popular infrastructure as code tools, essentially. So there's lots out there, but Terraform is particularly popular at the moment. It's a tool for building, changing, and versioning infrastructure safely and efficiently. Terraform can manage existing and popular service providers as well as custom in-house solutions. You can configure files subscribed in Terraform. The components need to be run a single application or your entire data center. And Terraform has this core concept of write, plan, and apply. So that concept is essentially you write your Terraform, you hit plan, it tells you what's going to happen. So what's going to be updated, what's going to be deleted, what's going to be created, and then you can decide whether you can actually apply that, so whether you're comfortable with those changes that are going to happen. And that is something, the features that you've got in Terraform, which are a lot more mature and easier to use than some of the other infrastructure as code solutions. So that is one of the big reasons why Terraform is so popular, because you've got that control, essentially, and visibility. And Terraform essentially is a solution for infrastructure as code. So we have to briefly look at what DevOps and infrastructure as code is, just to recap or to introduce to people who aren't that familiar with it. So DevOps essentially is when you're actually getting all of your stuff into production, that development and operations working together. And these are just some of the common tools that you might use for that. So Azure DevOps, Circle CI, Jenkins, Octopus Deploy. So I've used all of those in my career. But yeah, the list goes on and on, but those are some of the most common ones that you'd essentially use in DevOps. And then in infrastructure as code, we've got, on the Azure side, we've got ARM templates, which are great until they start to get complex, and then they're really painful. For anyone who's used them, I can see nods. Like, yeah, we've been burned. So that's when tools like Terraform essentially begin to become more appealing. Because of those strengths that we're going to go through with Terraform and why it makes the whole process with infrastructure as code a lot easier. But you have also got other tools out there. So we've got Pulumi, for example, which is gaining traction, which is becoming more and more popular. And Microsoft Azure have released now Azure Bicep. Azure Bicep is very similar to Terraform. So if you were to look at the syntax of Azure Bicep, it would look very much like Terraform. So if you are going to learn Terraform, it's worth bearing that in mind, or vice versa. If you learn one, you could potentially pick up the other. And then let's just look at that figure of 8 for DevOps, which a lot of us have seen before. That process, that ideal dream of when we're doing DevOps, we've got that process, code, build, test, release, deploy, orchestrate, monitor, plan. And essentially, when we're working with Terraform, it's one of those tools that we can use to make this happen. One of the tools, essentially, that we can plug in to make this process happen and make it a happy process so that we can work with our developers, with our operations teams, and have all of our infrastructure as code in a readable format. So why is everybody talking about Terraform? Why is it so good? Well, we've got this state management. So the state management in Terraform enables you to essentially have a state file which sits, for example, in Azure. You can put it in blob storage. Everyone points to it. And when you're running your Terraform, your state management, your state file will tell you what's going to happen, what changes are going to take place, what's going to be deleted. And it just keeps that state, essentially, in that file. So you can work against it and feel more comfortable and safe when you're actually doing your infrastructure as code. Terraform is cross-cloud, as we mentioned before, so you can range from multi-purpose giants from AWS, Azure, to one solution providers like Logentries. So solve the issue of provisioning complicated infrastructure often encountered with other infrastructures as code tools. So like I mentioned, ARM is great, but it can become quite complex quite quickly. So simple syntax that allows easy modularity. So a syntax that people can pick up and understand really easily, which is important because when we're looking at DevOps, we want everyone to work together. We want people to be able to pick it up and understand it as a team, not just having that one person in the team who understands it, because they've mastered, say, ARM templates and you know, they're the guy to go to. We want everybody to own it, everybody to be able to run, say, a Terraform plan, see what's going to happen and feel comfortable with that. And if they're not, they know who to go to speak to and actually tackle any issues that are there. So Terraform lets you define infrastructure as code. It will enable you to rebuild, change, and track change to infrastructure easily. Terraform provides high-level descriptive infrastructure. So Terraform has two core components, and this is really key when you're working with Terraform to remember this. We've got the Terraform CLI, and that's like the compute that sits over the top. And then we've got the Terraform language itself, and that's actually the language that you're writing to do basically your blueprint, your infrastructure as code. You're defining all of your resources. You put that into your Terraform language, and then the Terraform CLI over the top as you compute. And those are the commands that you're going to run to perform those actions. So yeah, so as I mentioned, Terraform CLI, it's a command line interface. It's a variety of subcommands such as Terraform init, Terraform plan, which we will look at. So Terraform CLI commands. Essentially, in order here, we've got init, that's initialize, validate, plan, and apply. So initialize, so you download your providers, you validate that your Terraform is valid, you hit plan, make sure you're happy with what's going to happen, and then you hit apply, and that will actually push into the cloud. So the Terraform language itself is the HashiCorp configuration language, essentially, and that is actually what, like I said, you write your infrastructure in. It is human readable, essentially. So like I said, it's something anyone ideally can pick up and understand. So the main purpose of Terraform language is to declare resources. So when you're writing Terraform, you essentially write, am I talking too fast? Can everyone hear me okay? Awesome. Yeah, so you're writing resources. So everything is a resource. So anything you want to create in the cloud, you declare it as a resource. And essentially, that's what you're working with when you're writing your Terraform. So Terraform configuration is a complete document in the Terraform language that tells Terraform how to manage a given collection of infrastructure, essentially. Just reiterating what we've already gone through there. So now to actually look at the code. So we've gone through the basics, what Terraform is, and kind of done the sales pitch around Terraform. So getting started, so that's the Git link at the bottom there. I don't think I can do the pointer, no. So the link there to GitHub is there with all the code that I'm going to show you. So what we're looking at here is the folder structure, essentially, what you'll find in Git. So I've got an Azure folder and a Databricks folder because I'm going to look at those two different providers. And in the Azure folder, essentially, we've got some pipelines. So that's when we're working with Azure Devops. And then we've got our Terraform folder. And within our Terraform folder, we have got a dev folder. And the dev folder represents your development environment. So per environment, we have a folder so that we can then change the configuration within those folders, essentially, per environment, and then deploy that accordingly. And then we have our modules. Now, modules are key in Terraform. Everything we do, ideally, we should do in a modular way. So in our modules, essentially, we have it broken down into the different types of resources, which I will show you in a second. So just firstly, if we open up that dev folder, we've got our main TF. Now, the main TF, essentially, when you run a Terraform command against this folder, it will, if it finds a main TF, that's where it reads from. That's like its entry point. So by having a main TF, essentially, it will pick that up, go into the main TF, and fire away and start executing your infrastructure as code. We've got a provider, and that is essentially where we list our providers, and we're going to be working with Azure, and later on we'll be working with Databricks, and a vars folder, which is where all of our variables go. And then in our modules folder, essentially we are looking at a Postgres instance, Postgres database, a resource group, and a storage account, and a virtual machine. So actually into the code. So here is some of our actual Terraform, so our actual Terraform language. So not the CLI, the language itself. So what are we doing? So firstly, we are declaring our remote state. So if you remember, I talked about the state file. The state file, as I said, we can store it in blob storage in the cloud, or you could have it locally. I wouldn't recommend it, but it's best to have it in a central location for everyone to point their Terraform to. So that is our remote state. And this is what we're basically pointing at: an Azure resource group, a storage account, a container, and then we're saying the key is essentially the name of the file that is actually the state file. And then we have our Terraform modules. So when we were looking in that module folder, these are our modules themselves. So we're declaring that we're going to have a resource group module. So that's where it is. There's a source file. And then we're declaring that we're having a storage account module, and then we point it to the right place to look at. And then it's important to pick up on here that we're declaring essentially a dependency. I don't know why I'm pointing my screen. You can't see that. We're declaring a dependency on the previous module. So what does that do? So when Terraform runs this code, essentially, because you're declaring that dependency, it will always execute the first module first before it's going to run any module that depends on it. So when you start declaring dependencies, it recognizes that relationship, creates the previous resources, the resources that are dependent on, and then will go on and create that storage account once the resource group is created that it needs to go into, which essentially is kind of important. You can't create the storage account until you have the resource group. So the provider.tf. So this is just an example working with Azure. Like I said, it could be any of the big three cloud providers. There are loads and loads of providers out there, but we're focusing here mostly on the cloud ones. So what we've got here essentially is we are declaring that we're going to work with the Azure provider. That's what we're interested in. And down here we've got some variables where we're going to pass in all of the security information that we need to be able to work with that provider. So we're going to work with an Azure service principal to be able to connect to it. So variables in Terraform. Terraform loads variables in the following order. Now, this is really key to remember when you're working with variables with Terraform, because there's different ways to populate your variables, essentially. And Terraform honors a particular order when it comes to looking at how it's going to populate those. So firstly, it will look for environment variables. So for example, if you're working on an agent in your Devops, your own VM that you're working with as your agent, you may set up your environment variables there as part of the process, and it will grab those first. Then it works with the TF-vars file if present. So I have one locally, personally in my solution, and that has all of my secrets and everything in there, and so that's automatically picked up for me when I'm working locally, but I never obviously check it in. TF-vars.json if present, and any auto.tf-vars, auto.tf-vars JSON files processed in order of their file names. And then finally, any -var file name. So this is when you're in the command line and you're doing like a Terraform apply, Terraform plan. You can essentially have a -var for every variable you want to put through to populate, and you would do that essentially, which we do in Devops a lot when we're pulling all of our secrets in from Key Vault in Devops for Azure. If you enabled a REST, for example, that would be parameter store. So that's a good way of getting all of those values in there in a safe way. So there's an example of just some variables I've been setting up in the vars.tf. So worth noting, you can mark it as sensitive, so we know that's a secret, so we mark it as a sensitive value. So Terraform treats that slightly differently, knowing that it is actually a sensitive value. There's lots of more stuff you can do with your variables here, but this is very basic, just an example of setting up some variables, essentially. So moving on to our modules, are there any questions so far? Is everyone happy? Okay. Yeah, so our modules. So like I said, modules are key with Terraform. It's a really great way of breaking down your infrastructure as code. So you haven't got it all living in one file. You're breaking it down into modules. And here we've got an example of a resource group. We are setting up a variable to begin with. Then we're setting up our resource, the actual Azure resource group itself. And if you notice there, we've got the prefix resource name with the same name. So that's just a nice way of being able to make sure all of your resources have the same naming convention, essentially. And it's a good example of how Terraform, you can work with strings and start building stuff up. So here we've got output values, and this is a really useful feature where we can actually grab values from this module and output them for use in the next module, and it in turn helps with our enforcing our dependencies. So moving on to module storage account, very similar to what we were previously looking at. We're just declaring a resource there, a storage account resource. And these are all objects within the Azure provider that are provided. So you've got the Azure provider, and those are all object types, and then you give it your own unique name. So what we want to note here is we're using a data resource. Now, we've got resource group name. We could just have a variable with resource group name, right? Why would we not do that? Well, what this is doing is that data tag above is actually grabbing that resource group name and going away and making sure it can actually get that resource. It's actually loading it in as an object for us. And it's just that extra bit of kind of security and knowledge that that resource actually exists when you're pulling it in, and then you're able to use it throughout your Terraform, essentially. Whereas if you have like a resource group name there, that can be any magic string. and it might not necessarily blow up in a way that is understandable and as readable as if you are making sure that you're handing it the actual object itself that you've loaded in from your cloud provider, and making sure that does exist, and then you populate those values at resource group name and that location. So yeah, so that's our variables from our previous modules. So essentially we output that from our previous module and we're able to bring it into this one and then load the data object and then again populate that in our resource group name further down. So PostgreSQL example. So variable from previous module again, using the data resource again. It's useful to note here that the password is coming from a variable. So we'll look at this in a sec, how we're actually parsing in our variable value securely, essentially, in our Devops pipeline, and then also just working with it locally. So moving on to a virtual network, and I appreciate there's a lot going on here. We are creating a network, creating a subnet, creating a network interface. Again, that all resources. It's all just knowing what the name of the resource is that you want, giving it a unique name, and then making sure you're passing in all the data that you need. So the prefix that you want, and then grabbing the location and the resource group name from your data object again. So sort of building it all up, and it glues it all together really nicely. And when you're running your Terraform Validate and your Terraform Plan, it will flag up straight away if anything is wrong, which isn't necessarily the case with some infrastructure as code tools. You get burned further down the line, but this is all nicely tied together. So here's our virtual machine itself. So we can see here we're referencing our network interface. So when you look at the code, if you were to go onto GitHub and look at the code, you'll see that it actually references that network interface that we just created. We're creating that relationship, so Terraform knows that it needs to execute in a certain order for this to work. So it's going to grab that network interface once it's created, and it will then be able to populate the network interface ID. So moving on to the CLI itself. So we've looked at a load of Terraform code. Lots and lots of Terraform code. And now we want to move on to actually executing the CLI, the compute. So what do we first want to do? Well, as we mentioned before, we want to run the init first, the initialize. What does that do? Well, it's going to go away and look at what providers do you want, what you're actually working with. And we can see here it's telling us, this is an example output from the CLI. I went away and got Azure for you. I've downloaded that version for you. And it creates a .terraform folder, essentially, where it stores all of that information for you. And essentially, that is always just a folder you'll have locally or in your DevOps environment that is just spun up. And then you can tear it down when you're not using it. So then we move on to Terraform Validate. So this will actually validate your Terraform code. So when you've written a load of Terraform, you think it's great. And then you can hit Terraform Validate and actually see whether it's great or not and whether you've actually done anything wrong. So like if you've named something incorrectly, for example, it will essentially bring that up for you and let you know that if anything is configured incorrectly. What happens if it is wrong? There's an example error that it will throw back at you. So I've deliberately named that resource group name wrong. I've knocked the E off. Immediately comes back to you and says, you've named that wrong. So by running the validate, it gets rid of all of those bugs, essentially, that you might find further down the line, especially if it's somebody who's not used to doing infrastructure as code. So if you're trying to bring more people on board into working with infrastructure as code and being part of the team, having a tool like Terraform that gives you these features out of the box that are really easy to work with is super useful. And in the long run, this gives you a more robust team and a team that feel that they're working better together, essentially. So now we're going to look at the Terraform plan. So as mentioned, you run a Terraform plan, and it will come back and tell you everything that's going to happen. Oh, wow, 5 minutes. OK, so I'm not going to get through everything, but all of this is in the Git repo. So you're welcome to go and have a play with that. So what we're doing here with the Terraform CLI plan is we are entering a password. Note there that it's actually prompted for the password. Why did it do that? I didn't give it that variable in any way. So because it couldn't find it, it comes back to me and says, you haven't given me this value, so can you please type it in, please, because I need it, because you've told me that I need it. So prompts to supply the password. So when we actually get our plan back, this is an example of getting the plan back. What we actually see, you see those little squiggles there, that's telling us there's going to be a change, and the change is that we've changed the password. So it's telling us, I'm going to change that password, so I'm changing this resource for you. If it's going to delete something, you see a red line. If it's going to add something, you'd see a green cross. And when working with a plan, so if you're not used to working with like a CLI, it's a little bit alien to you, or there's a lot going on, there are tools out there that will help you. You can actually run the plan, push it into a JSON file, and then essentially this tool here, for example, you can load that JSON file into it, and it actually visualizes the plan for you. So you can see what's going on, and that is really, really useful to actually understand what's going on, especially when I'm working with people who aren't used to working with infrastructure as code. When you show them this, like, oh yeah, I get it now. I understand what's going to happen, and they feel more part of the process and part of the team. So finally, the Terraform apply. So this is an example of when it's worked. And it's all happy, and it tells you how many resources have been created, how many have been changed, how many have been destroyed. If it goes wrong, say, for example, we give it a password that doesn't validate, we get an error like this. And that's what we want. We want it to break. We want it to come back and tell us, so we can immediately react to that. We don't want it to go wrong in a way that we don't understand, that's happening further down the pipeline, and the error we get back to is not understandable. This is really readable, and this is understandable to anyone really, essentially on your team, to be able to understand what's going on. So the CLI graph, running the graph command, and the command is just there, gives you a picture of the entire infrastructure. And obviously I wasn't able to fit it all on, and you can't really read it very well. But everything is pretty much there that we were just talking about. And it's just a diagram there of all of your infrastructure that you've built up. Again, really useful for the whole team to understand what's going on. So there's our state file living in the cloud. I'm going to skip through it. State file is always locked when in use, so you can't have two people running Terraform at the same time. Really useful. You don't want your infrastructure to blow up because two people have made changes at the same time and overwritten somebody else's changes. Always a good feature. It locks the state file. You can't have two people running at the same time. You can explore your Terraform state with commands such as Terraform state list. So you don't have to go into the massive state file. You can run commands, and it will show you what's going on with your state file. You can add and move items to the state file as well. This is a Devops example. I'm going to run through it really, really quickly. So this is an Azure DevOps pipeline. There is so we're grabbing stuff from Key Vault. It depends on the previous job. And then this is a marketplace extension for DevOps in Azure that enables you to run Terraform. You don't need it, but it is really good. But you don't need it. Essentially, because it's command line, this second task here is a bash command. You could just do it yourself and just run bash. It's whatever you feel comfortable with and what your team feel comfortable with. So here, it's worth noting here, we're parsing in all our keys from our key vault we saw in the previous slide. So we're grabbing our keys securely, and then we're parsing it into our Terraform apply there, and we're giving it all of our secure information. So the end result, essentially, is this. So this is basically in Azure. We've got all of our resources there that have been created using Terraform, essentially. So if you were to pick up the code that I've supplied and were able to access Azure, this is what essentially you would end up with. So I don't know how long I've got left. Is it like 3 minutes, 2 minutes? Right, 2 minutes? 1 minute, okay. So quickly, there is a Databricks provider, as I mentioned. In the Databricks code that I provided, everything is in one file, just so you can get yourself going. I don't recommend you do that in production. So you don't have the dev folder, you don't have the modules. It's literally just, this is how to work with the Databricks provider, and that is an example of working with the Databricks provider, and you're specifying you working with the Azure provider as well. You're working with them hand in hand. The Databricks provider is pretty awesome. Yeah, Azure provider, Databricks provider. And then it's just the same thing. It's just showing you how to set up a resource group, Databricks workspace, secret scope, pat token, your secret, and just building all of your usual Databricks objects that you want using the Terraform, creating a notebook there. And that's the final result, essentially. Thank you. Sorry, I had to rush that at the end. I don't know if we've got any time for questions, but I will be at the Advancing Analytics stand after this if you want to ask me anything. Yeah, thank you very much for coming. Okay.